Dear students of 11th class, subject physics, Assalamu alaikum. Let's continue this projectile motion and projectile fired at an angle with the at a certain angle with the horizontal. In the last lecture, we have derived relation for the equation of trajectory, which comes out to be parabolic equation. Now, today we'll move ahead. We will derive relation for time of flight. Time of flight means time taken by the projectile to return to the ground. Since here the motion from O to A and A to Q are symmetrical. That means time taken from O to A when it moves upwards, which is called time of ascent, is equal to time taken from A to Q when it moves downwards, which is called the time of descent. If the time taken by the projectile from O to Q is T, capital T, then time of ascent will be half of the time of flight and time of descent will be half the time of flight. So time of flight is total time taken by projectile to return to ground. Let it be denoted by T. So time taken by the projectile from O to A is called time of ascent. Time of ascent, that is half of the, that will be, since this is symmetric, this will be half of the total time of flight, T by T, and time of descent, time of descent. T, that will also be T by 2. Now, we will now derive relation for time of flight. Since we will consider the first part from O to A, this projectile is moving with a vertical velocity, whose initial vertical velocity is u y is equal to u sin theta. This is the initial velocity, and it reaches the highest point A. At A, it momentarily stops. This velocity becomes 0. That means Vy is equal to 0. And time from this to this, it takes the half of the time taken by the projectile from this initial point to the final point when it hits the ground. So T is equal to this. Now we will use velocity, or we can say velocity of projectile at any instant, at any time t along y-axis is given by, yes, Vy, final velocity, is equal to, velocity at t is equal to uy plus ayt. Here also this acceleration, since this is moving opposite to the gravity, ay, that is equal to minus g. Substituting in this, Vy is equal to 0, uy is u sin theta plus ay is minus g into t is t by 2. This is called u sine theta minus gt by 2, which implies t is equal to 2u sine theta divided by g. Question first. So this is the time of flight 2u sine theta by g. Now we'll now see the maximum height obtained by the object, by the projectile. Maximum height. See, expression for maximum height. Maximum height. This A point, this A in the diagram AB. AB is the maximum height attained by the projectile. Now we will take third part. Maximum height denoted by h. Now it is the greatest height. So it is the greatest height to which the projectile rises above the point of projection. So we'll write for expression for h. The distance, we'll write the distance covered by projectile distance covered by projectile in time t along y-axis is given by. We'll write this equation. How we can write y in the distance traveled, covered or traveled by the projectile in time t along y-axis can be written as y is equal to, we'll take the motion of the object in the vertical direction. Y is equal to uy initial velocity ut plus 1 half at square. वही रिलेशन हम यूज करेंगे. u यहाँ आएगा uy t into 1 half a y t square. और यहाँ पर आप देख लीजिए uy is equal to it is u sine theta, vertical component of velocity u, ay is equal to minus g and t टाइम, दैट इज चूँकि हम ये यहाँ तक लेते हैं एक 0 to a एक फुल यहाँ तक जो टाइम आता है टाइम ऑफ असेंट, तो यहाँ तक टाइम ऑफ फ्लाइट का हाफ दैट इज असेंट. दिस इज इक्वल टू अभी हमने निकाल दिया t is 2u sin theta by g and t by 2 is u sin theta by g. Now we will substitute this u sin theta by g. We'll get y is h. यहाँ पर देखो y goes h. Y is equal to h. H is equal to u sin theta into t. t के बदले लिखेंगे हम ये that is u sin theta divided by g. फिर आएगा बीच में प्लस 1 half minus g into t square, that means u sin theta by g whole square. t का स्क्वायर, इस t का स्क्वायर यहाँ. हाँ, h is equal to u and u is u square sin square theta divided by g. यहाँ ये माइनस बाहर आएगा, माइनस u square sin square theta g और यहाँ पर g स्क्वायर आएगा, एक g और g कैंसिल, नीचे एक g रहेगा, तो ऊपर रहेगा u स्क्वायर sin square theta divided by g. So if we these are same, if we subtract them we'll get here it is see यहाँ पर एक चीज़ आपको u 1 half दिस इज, इसमें कहीं पर हमने डेरिवेशन में देखो हम क्या करें, टी इट इज is u square t by 2, this, or it is here it is u square see here, actually here was 2, we'll write here 2g. now h is equal to, this is u square sin square theta by g, and this is half of u square sin square, we will get u square sin square theta by 2g. This is the expression for maximum height. Now range or distance covered by, distance traveled by projectile in horizontal direction. See answering diagram. Distance, range is distance traveled by the projectile in horizontal direction. So from the point projection to the point when it hits the ground, we have to calculate OQ. So here this is denoted by R. Now obviously we will take the equation of the projectile in horizontal direction, or there is one more thing. If we are asked to find this, see, the projectile moves with velocity ux, which is u cos theta in the horizontal direction, and the time taken by the projectile to reach here is t, which is the time of flight. So we can write horizontal range R is equal to range, any distance, that is equal to velocity into time. Velocity here is u cos theta into time is time of flight t, that is equal to u cos theta into time of flight t, that is equal to recall, that is 2u sin theta, 2u sin theta divided by g, अभी हमने निकाल दिया, और that R is equal to, see here to u square, इसको अलग से लिखेंगे अब, twice sin theta cos theta, twice sin theta cos theta divided by g, but twice sin theta cos theta is sin 2 theta, which is equal to u square sin 2 theta divided by g. When is R maximum, or when is R maximum, और कब मैक्सिमम होगा, when sin of 2 theta has the maximum value, but sin of 2 theta has value of maximum value of sin is 1, that means sin of theta कब 1 होगा, when it is 90, that means 2 theta is equal to 90 degree, or theta is equal to 90 by 2, which is equal to 45. So when we fire a projectile at an angle of 45 degree, we will get the maximum range. That's all. Thanks.